equations. I'll just go briefly over again so that we get the concept. Once you get the concept, because you need it, you need the concept as we go on. So we say A is equal to B minus U over T. We said the parenthood S is equal to average velocity times T. We said V squared is equal to U squared plus what 2AS. And then we said S is equal to UT plus half AT squared. So these are the equations. So you realize that we found an equation for A, we found an equation in terms of velocity, and we found an equation for T, for S. Okay, you can also work things out to get an equation for T. T, an expression for T. Okay, this is more or less, this is actually a kind of a quadratic equation with respect to T. We have T to the power 2, so quadratic equation with respect to T. So when you are dealing with equation like that, maybe, and you are supposed to find T, you may have to apply the quadratic formula. Alright, so that should be remembered. So these are the 4 equations. You can have them at the back of your mind. But if you want to derive, always start from first principles, okay? You know your distance starting from here to the point. So we are starting with U, your final velocity is V, the change in velocity is acceleration, you took time T, your distance that you traveled is S, or displacement is the same as also displacement, okay? So you have all these variables and you start using them, okay? First of all, you can look at the parent formula that you use, and these. And then from this, if you want V, so you want V, that means you want to make sure V is in the equation. All other variables, when they are out, they are okay. So just substitute for any of the other equations, okay? Any substitute either find the expression for V or T or A here. There's no A here. V or T or U, and then substitute in this, okay? Then you get the equation. This equation becomes important when you are only given one, the starting velocity. Here it becomes important when we are not giving time, but we are giving the final and then the initial. Okay, so what you do is that you listen to the question. If the question says a car starts from a point A, moves with initial velocity this, okay? So remember that velocity is also equal to what? Your distance over time. So it's moving with, let's say, velocity of 2 meters per second. Then it's telling you that when it goes 2 meters, it is the time that would have elapsed is what? 1 second. Okay, if it goes 4, it's 2 seconds. So that principle should also be at the back of your mind. So try to picture it like that. When velocity is given to you, try to split it into the distance that has been moved in 1 second. You get it in that way. And then when acceleration is also given to you, try to reason it out as the change in it. So changing from U to V over a certain time is my acceleration that has been given to me. And then when distance is given to you, think about it as the change in position from one side to the other. There's the space between them in terms of the space, that is the distance, okay? If we are looking at the direction, then it becomes displacement, okay? Then the time for those kind of movements. And that is how you should, if you think about it that way, sometimes you may not need a formula. Because if I tell you a car is moving with velocity 20 meters per second, in 5 seconds, what will be the distance? Velocity is this, time is this. So what is the distance? S is what you have to find. You can easily get it without the formula. If it is moving 20 meters per second and 5 seconds, so it means it moves 20 meters in 1 second, okay? And we are going 5 seconds. 2, 3, 4, 5. So 1 second 20, another second 20, another second 20, another second 20. So you can get it 20, 20, 20, 20, and that is going to give you 100. So 100 meters. If you use the formula 2, you get it. So the formula